Okay, good afternoon. Our project for the Sophomore Design Lab Section 2240 will be a PV battery system. Our presentation will be presented by...
Hi, I'm David Abadarian.
Hi, I'm Jaime Ramos.
I'm Evan Franklin.
And I am Zacharias Contreras. So let's go ahead and begin with the presentation. Today I'll be taking over through the objective of this project, that is to develop a DC-DC converter system that utilizes photovoltaic solar cell to power up a battery and ultimately use that battery to power a DC load. In our project, our DC load will be a amp. For the requirements of this project, we'll be going over the power electronics. We'll need to implement a boost converter, a buck converter, and have a bidirectionality DC-DC implementation characteristics. The main budget for this project is going to be $150. And just the general background for this project, we'll be using a solar panel, which is a photovoltaic array that uses photoelectric effect, as well as battery integration, which is going to be used to operate the voltages regulated in our system.
I'll be giving a presentation on the background converter systems. And first off, we'll be implementing the boost and the synchronous buck converter, which would operate for voltage step up and voltage step down throughout the circuit. The main topology of the bidirectional converter would be the buck converter, and this would be used to charge the battery through the solar panel and to discharge the battery to our power amp in times where the solar panel doesn't provide any sufficient power. Over the simulations, we have the synchronous buck converter, which is capable of bidirectional power flow, as mentioned previously, and also the boost converter, which would upscale the power flow from the solar panel towards the rest of the circuit.
Noteworthy devices for our circuits was an IR2104, a half-bridge MOSFET gate driver that takes a low power input and allows it to feed out a high current for MOSFET gate drivers. The other device that we used was an Arduino Uno, and we did this due to the fact that Arduino has a vast library of resources that make it very easy to find and create a code for our situation. Our code here is a feedback code for our buck converter. And the way this works is we set a constant voltage as an input, and we run a feedback voltage at the end of our converter to feed back into our Arduino, which compares it to our constant and tries to balance it out to keep it constant and self-regulating.
For our prototyping, we have split our project into the buck and boost converters. For our buck converter, we were able to successfully create signals for our synchronous buck converter design. And for our boost converter, we were able to successfully boost an input voltage to the operating voltage of our amp, which ranges from 5 to 25 volts. For our buck converter, we were able to successfully buck it down to the charging voltage of the battery that we would need. And for our boost converter, with 8 volts and 6 volt inputs, we were able to boost to around 12 volts, which is well within the requirements for our amp. Finally, here's a little presentation of the amp itself working. This has been our group project for Innovation Day. Thank you for your time.